Hello everyone, Miss Katongo here. This is a continuation of our physics related problems. Before we get into the problem that has been displayed on the screen, don't forget to like and subscribe to my YouTube channel. Let's get into the problem. Determine the displacement x of the particle from the equilibrium position at t is equal to 0.5 seconds. Using the displacement as a function of time equation, we will have x as a function of time being equal to a cos of wt. We have our angular frequency being determined previously in the question as 22.4, and our time being practically given as 0.5 seconds, and finally our amplitude, which we obtained previously as 0.05 meters. Replacing that in our equation, we'll have our amplitude, which is 0.05 meters, cos of the angular frequency, which is 22.4 times the time, which is 0.5. So therefore we'll have our displacement x as 0.01 meters. In the other question, we have determine the velocity and acceleration of the particle when t is equal to 0.5 seconds. Velocity as a function of time equation is given by negative a w sine of omega t, where we have our negative aw being the maximum velocity sine of the wt. Our time given is frankly 0.5 seconds, and our angular frequency is 22.4. Replacing that into our equation, and finally, previously we had obtained the maximum velocity as negative 1.12 meters per second. Therefore, replacing that into our equation, we'll have negative 1.12 sine of our angular frequency being 22.4 times the time, which is 0.5, and therefore we'll obtain our velocity when t is equal to 0.5 as 1.1 meters per second. The other part of the question reads, or rather says, we have to determine the acceleration as well at the same time. So our acceleration as a function of time equation is given by negative of a w squared cos of wt, where we know that negative a w squared is the maximum acceleration, which we had previously obtained as negative 25.1 meter per square second rather. Replacing this into our equation, we'll have negative 25.1 meter per second squared cos of our w, which is 22.4, times our time, which is 0.5, and we'll have our acceleration being 5.1 meters per second squared. Don't forget to put your calculator in rads.